Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 265, I chat with David Meyer, founder of Kordz, and Kevin Taylor, a consultant for THX, about THX HDMI cable certification. So,
netcasts you love
from people you trust.
This is Twit.
Bandwidth for Home Theater Geeks is provided by CacheFly at CacheFly.com.
this is Home Theater Geeks with Scott Wilkinson, recorded July 23rd, 2015. Episode 265, Getting What You Paid For in HDMI Cables. Hey there, Scott Wilkinson here, the Home Theater Geek and editor of avsforum.com. This week, I have two guests on the show. David Meyer, founder of Kordz, Kordz, maker of HDMI cables and probably some other types. Hey, David, welcome to the show.
Thanks for having me.
And you're all the way from Melbourne, Australia, one of the farthest guests we've had yet on the show. So welcome from down under and in the dead of winter there this time of year.
Yes, it is. Yeah, it's still dark outside and it's actually quite cold. So, yeah, envying a little bit of heat that you've got over there at the moment.
Well, I hope you're indoors and nice and toasty as it is.
Absolutely.
Also, we have Kevin Taylor from Montreal, so truly an international show today, who is a consultant for THX. Kevin, welcome to the show.
Hi, Scott. Thanks a lot.
You
Good
bet.
to be here.
Yeah, it's great to have you here. Those of you who are tuned in live at live.twit.tv or logged into the chat room from there or at irc.twit.tv can post questions for David and Kevin, and I will pass along as many as I can. So the topic for today is HDMI cables and the THX program for certifying their performance. I'd like to start with kind of a basic outline of what HDMI is and what an HDMI cable needs to convey. Now, Kevin, you sent us a couple of pictures to illustrate this particular point, so why don't you begin?
Sure. So if you can pull up that first image, it gives you at least the sort of pinout of what the HDMI connector is. So what HDMI is basically just a digital interface that sends audio, video, and all the ancillary control information as well. So it's sort of the extension of DVI, and it's giving you the best sort of high-quality picture you can get. So on there's 19 pins, and it's basically broken up into three different groups. So there's high speed, which is really where the video, the audio, and all that control information lives. There's low speed, which is where the EDID read and writes happen, and also the HDCP encryption. And then there's the low speed, or the DC power, which is really around power up. That gives you the 5 volts and does the hot plug detect. So those are sort of the three components. So we can see in more detail on the next image just sort of how those actually play out and what happens within the HDMI connector. And this sort of falls into some of the issues that happen. So you can see that the image doesn't necessarily show as nicely as it did before, but I think the text is black. But the top pin is the 5 volts. So basically, there's a power-up sequence that HDMI requires. So 5 volts goes from the source to the sink, and that basically tells the sink that there's something trying to talk to it. It will send a hot plug detect back, and then that is what triggers the EDID read and write, as well as the HDCP. And then once everything's all certified and the encryption's there and everybody's happy, then the data starts flowing. So there's a regimented process to actually make that happen. That happens within the connector. And then
is that process of starting up, is that what we refer to as handshaking?
That's right, exactly.
Okay. It seems to me that, when you start something up, it does take a little while. It takes a few seconds anyway. Is that typical?
Yeah, I think it's partly the HDCP as well, just because the HDCP is at a slower speed, and it's not an instantaneous on and off switch because the TV needs to make sure that the encryption's there. So sometimes what might happen is you actually, rarely now, but you'll actually have a screen pop up and it'll be all static, and then all of a sudden it'll lock in. And that's because initially the HDCP didn't necessarily have the read writes correct, and then all of a sudden it locks in and says, "Yep, this is a viable TV," and then it starts sending it the data.
And let's make sure everybody understands all of this alphabet soup you've been throwing about here. HDCP stands for?
So it's the high definition content protection. So that's basically anything that's Hollywood produced. It has the encryption in there, so that way you can't have unprotected data going over an HDMI cable.
So you can't steal it, in other words.
Exactly.
Or probably not. Although I don't think there's ever been a copy protection scheme that was completely invulnerable to attack, right?
For sure, for sure.
You know, so if you're dedicated enough, you can probably get around it. But for most of us, you know, it just means that we can't just casually copy it.
That's right. It's just it's what actually causes a lot of the issues with HDMI cables in general. Like when there's a lot of issues happening at longer lengths, a lot of the time that's what the culprit is.
Ah, well, we're going to get into lengths in a second here. But
Yeah.
first, define EDID as well. That was another term you used.
Yeah.
EDID.
I can't remember exactly what EDID, the extended display ID, I believe. So it's basically
I believe that's correct.
So it's in the monitor, and the source and the sync both have an EDID which says this is what I can support. So if the Blu-ray player can support 1080p 60 at 12-bit, and then the monitor can also support that, then it'll send that sort of mutually decided format. And then if one of them is sort of a lower resolution, if the TV only supports 720p, that's how the projector or the Blu-ray player would know to only send a 720p signal to avoid any conflicts.
Mm-hmm. So, David, Kevin mentioned a little while ago lengths and long lengths, and I've long maintained that, you know, the length of an HDMI cable is pretty critical. It can't really go too long before you start running into problems, right?
Yeah, that's right. The interesting thing is that the errors that actually happen in a long cable that stop long cables operating actually do still happen in short cables as well, just maybe to a lesser degree and still at a viable level. But further to what Kevin was saying about those three distinct sort of protocol subsets of DC, low speed and high speed, the length actually does then come into all three of those. With DC, it could be a matter of attenuation over a length, which is why they actually have a current restriction, how much power can be pushed over the line to stop too much attenuation. In the low speed, which is actually regarded, the DDC channel in particular, which is what carries the EDID upstream from display to source and the HDCP keys from source to display. And anything in between is that's actually the area where most of the errors occur. Historically, they've occurred. So HDMI themselves have recognized that as actually being the number one cause of interoperability issues with HDMI, and cables actually being number two. So for anyone that thinks the cable shouldn't make any difference, it absolutely does. And then in the high speed, we end up with very significant issues, and there's capacitance and a whole bunch of other things that actually contribute to that as well. So length impacts everything, and it really does matter, and that's why it is so restrictive.
Kevin, you sent a couple other photos, 3 and 4, to illustrate some things about length. Let's take a look at those.
Yeah, perfect. So this screenshot really just shows the gamut of frequencies, and this doesn't even include the 4K 60, 18 gigabits per second that HDMI 2.0A sort of is talking to. So I just wanted to sort of emphasize that when you go to higher resolutions, the bandwidth of the signal starts going up significantly. And the one thing to remember, like when I think of cable length, I try not to think about in terms of cable length, because it's really about signal loss. Because cable length, it could depend on the gauge of the cable, the frequency of the signals. There's a whole bunch of other factors that define the length of an actual cable. So when you look at the higher frequency signals to get your 1080p 60, your 4K, or even your 4K 60 with HDR, you're talking about a lot more bandwidth, and that's going to make it a lot harder to get it down a longer reach cable. So that's sort of one thing to think about, that although maybe at 720p or 1080p there wasn't a lot of issues, as we get to these higher resolutions, suddenly cables are going to make a much bigger difference.
And what was the next photo?
So it just shows a frequency response of, I don't know if it's, yeah, perfect. So it just shows you the sort of the loss. So the main thing to look at this is that the lower the curve, the more loss that the cable is seeing. And then as you go down the frequency axis, that increases the frequency, and you'll see that it's actually getting more loss the further down you go. So again, the frequency for 4K 60 isn't even on here. That's at 3 gigs. So the loss is significantly lower than anything else you've really dealt with today.
The loss is lower, meaning there's less loss?
No, sorry, more loss. More loss, sorry.
Okay.
Yeah.
And by loss, do you mean just the amplitude of the signal?
So it's a combination of things because it depends on the frequency of the signal. So it doesn't necessarily just attenuate and shrink down. There's a whole frequency spectrum that happens, and that's sort of where the jitter element comes in. So when you actually restore the signal, usually you can't even see an eye opening at that point, and the equalizer will extend it and stretch it, and then it actually applies gain to different frequencies at different rates to get that signal back. So it's attenuation is a good way to think of it, but it's more complicated than that.
Chickenhead 21 is bringing up a question that I'm going to bring up a little later. So Chickenhead 21, stay tuned. Meanwhile, Dr. T in the chat room is asking, will DisplayPort make HDMI obsolete? I believe DisplayPort does have a higher potential bandwidth than even HDMI 2.0 at 18 gigs. Am I correct about that?
Yes, that's correct.
Yeah, it does by a margin, but it's still not a significant headroom.
Not tremendously more, but somewhat more.
Yeah, a little bit. Yeah.
Yeah. So what do you guys think? This is a question that I've often asked people in the cable business particularly. Well, in all of the video business. DisplayPort does have a little bit more bandwidth and so on, and yet HDMI is essentially ubiquitous. I mean, it's on every single product. Few TVs have come out with it with DisplayPort. Computers certainly have it. Do you see it supplanting HDMI, or is HDMI so firmly entrenched that that it will always be the primary interface for consumer products anyway? David, let's start with you.
Yeah, it's a good question. DisplayPort came out later than HDMI, and as such, actually even included HDMI as part of the specification, and the fact that DisplayPort is actually able to throughput the HDMI TMDS signaling. But really, they actually are expanding into different markets. As you mentioned, with computers, IT generally, DisplayPort is getting more and more firmly entrenched. It was favoured by Apple some time ago and continues to roll out in that space. But in the broader audiovisual space, HDMI still enjoys 100% adoption and is really not going away anytime soon. So I see the two as just running concurrently and not necessarily looking at one, surpassing or replacing the other.
So they can coexist, in your opinion?
Absolutely. Yeah, they already are. Yeah.
Kevin, you agree?
Yeah, I do. Like, it's just HDMI is so prevalent everywhere in the industry that the idea of DisplayPort supplanting them is pretty unlikely. I think you'll see a lot more DisplayPort happening on computers, potentially tablets and things like that, where there's less headroom and maybe the smaller connector is more useful. But in terms of consumer AV gear, it's always going to be an HDMI connector going in, or at least have one available.
Well, I had planned to bring this up later, but there are quite a few people actually in the chat room bringing it up now, so what the heck, why not, huh? And that is the question of whether or not expensive, exotic HDMI cables really make a difference. It's a digital interface. It conveys bits, and the bits either get there or they don't. And whether or not somebody buys a $500 HDMI cable or a $20 HDMI cable. I mean, the purpose of this show is talking about certification and testing, and we'll get to that in a minute. But since everybody's bringing it up now, I'll just bring it up now. What the heck? And that is, is there a real advantage to very expensive, high, exotic type cables or not? David, I know you had something to say about this.
Yeah, absolutely. This is actually one of my favourite questions, having been an HDMI adopter for a full decade now. The answer is that I would say no, there's not necessarily a big advantage to going those super expensive exotic cables, as you say. However, that's not to say that just any old HDMI cable will do. What we're talking about here is not exotic. We're not talking about materials that are sourced from some asteroid or from another planet,
Right.
or some extraordinary geometries that somehow defy the laws of physics. Where what we're talking about here is quality and integrity. Where we're talking about a transmission line which is inherently imperfect. So we're not really, in an ideal world, we're seeking perfection, but it is imperfect. So what THX certification is about is bringing a new level of testing and certification to an interconnect to ensure that it actually operates the way it should. And producing anything to a higher quality is always going to cost more, but does that have to mean hundreds of dollars? No. It may mean extra tens of dollars, but not hundreds of dollars, depending on the length, of course. So exotic, no, we're not into that either. We're into making good quality, high integrity. It's like looking at a prestige car versus an exotic car. It's are you going to pay hundreds of thousands of dollars for a car? It's fun, yeah, sure. But what we're about is making one that is very high integrity and does exactly as it should do.
Mm-hmm. No more, no less, huh?
Absolutely, absolutely. We're not actually claiming to make flesh tones better through an HDMI cable. That's just rubbish. You know, we're about actually delivering everything intact. We're talking real-time delivery of up to 18 billion bits per second with absolutely no buffering whatsoever, and we've got to make sure every one of those bits gets through intact.
Mm-hmm. Mm-hmm. Kevin, what's your response to that very oft-heard question about, oh, well, you know, hundreds of dollars, thousands of dollars for an HDMI cable. Don't need to do it. Yes, you do. No, you don't. Yes, you do.
No, I think David was dead on. Like, I think for the lower lengths, if you're going 6 feet or less, even at the highest data rates coming out at 18 gigs a second, you don't need a fancy cable. Like the monoprice 28 gauge cables will likely do it for you, and that should be fine. If you're going further, that's where you're going to probably run into some issues if you're just going off a cheap off-the-shelf solution. We've done some testing already in the lab of cables that are like 4 to 5 meters, and at 1080p, or sorry, at 4K 60, we're already seeing failures. So it is a very stressful signal. So once you get to that higher limit, and at THX, the program isn't built to try to justify those ridiculous, thousands of dollar price tags. It's really just to help customers see a cable that's actually been vetted and proven and tested in a sort of unbiased setting to make sure that the performance is there and that it will hit the cable lengths as required. It's just, it's really hard to know what cables to go with without it, because we've seen so many that haven't had the quality there.
Yeah. Well, since we're now talking about just making cables that function properly as expected, and we don't really, I think both of you would agree, we don't really have to spend tons of money to get that. But what we do need is some way to know, to be confident that the cable that we buy will perform as expected. And that really takes compliance. So let's start our compliance discussion with talking about how, cables are tested already by various authorized testing labs, right? Under the auspices of HDMI. Is it HDMI licensing? I forget which group would actually, it is that. So they already do some testing in order for the product to be able to legally put the HDMI logo on their product. So let's start with that, and then we'll move into what THX is doing sort of over and above that. And either of you could start with something about how basic certification works. What are they looking at? What are they looking for? What are they certifying?
Okay, if I can pick that up, again, been part of this process for many, many years. To quote the man who actually heads up certification program for HDMI, still does to this day and has done since day one, he simply says the eye doesn't lie, referring to the eye diagram and the fact that it is actually a fundamental measure of bandwidth. However, with the original, what they call Category 1, being what eventually became known as standard HDMI, is tested at 720p level. It really has it has its roots in history. This was a test that was defined in 2003. After all, it's a long time ago. So, and that is actually still prevalent to this day. I don't think anybody, I don't know of anyone that actually makes a cable, especially in short length. We couldn't make anything less than high speed if we tried, but to make one at that level, 1080p, especially 1080p 60, really has been that minimum bench for most of that decade, and now we've got this UHD, which is raising the bar and making things more difficult to get a pass. But the one thing I'd like to add, though, is that it is extremely easy to make an HDMI cable, put an HDMI logo on it, put the high-speed label on it, and release it to market and not necessarily have it be compliant, which is why HDMI themselves actually do have a compliance team, which is actually a bigger team today than it's ever been in their history because they are continuing to police it. But they've said to me before that unfortunately there's sometimes not a lot they can do about false advertising. So there's
wait a
no
second
assurance.
though. But wait a second. They do require that people run these go through the compliance testing process in order to put the HDMI label on, and I guess there's a high-speed label as well. And I would assume that the basic HDMI certification would include testing for however high speed is defined. So are you saying that there are companies out there who will do that without running through that compliance testing?
The main thing that HDMI licensing in their compliance actually do look for at the moment is that the cable is actually coming from a current HDMI adapter. And making sure that it comes from an adapter means that it actually has some traceability. But considering that most of the cables that are available in the marketplace are being sold under brands that are not in themselves HDMI adapters, there exists this big firewall between the consumer and the factory, where the factory may be someone in China and the factory name that nobody in the West has really heard of. So there is no way, there's no checks and balances for the consumer to actually be able to check that the cable that they've got is in fact compliant. So that's why there is a compliance team that's out there trying to track down and make sure that product entering various countries or even exiting China is in fact from an adapter. But whether it has actually run the gauntlet of tests is another thing entirely. I've seen hundreds of examples of cables that are claiming to be high speed that aren't even compliant, fundamentally not even compliant.
Wow. Well, what is the definition of high speed? What must the cable be able to do in order to be legitimately called high speed?
Okay, the first thing they do there is to ensure that we have full continuity and operation on the cable itself, that the connector actually fits within the dimensional tolerances and limits as set by the specification, which is no mark of quality, by the way. It just has to fit within the dimensions. And then from there on, it's about making sure that all the protocols work, that we actually do have the voltage that actually does fit between 4.7 and 5.2 volts, that the DDC works, and that the eye diagram is actually going to be functional to the test limits. And at high speed, it's actually tested at 340 megahertz clock, which is the equivalent of 3.4 gigabits data rate per channel.
Wow, and that's considered high speed? I mean, that's very low compared to what we need today.
Yeah, it is. Yeah, 3.4 per channel, 3 channels is 10.2.
Okay, all right. Per channel. I forgot that part.
Yes. yeah, that's okay. But then there was also, when the HDMI 2 specification was released, it was announced at that point that a new equalization profile in the sync would enable higher levels of EQ to the signal coming in to enable it to boost up to an aggregate 18 gigabits per second. But I actually kind of challenged that at the time, and there has actually since been revisions to recognise that may not always in fact be the case, especially depending on length, because there's, as Kevin mentioned earlier, it's actually a very complex beast.
Kevin, do you have anything to add in terms of just sort of basic testing before we get into THX?
Yeah, I mean, I think the one sort of difference, the one thing we found with the ATC testing is that it's very specific. They test each element on its own. So they look at the high-speed band channels, they do a bunch of fancy tests, then they look at the DDC channels, and they do a quick measurement to make sure things are going through, and it's a very regimented display. So they go through it, and then they're done. Whereas what we're finding is that there's more time that's needed to make sure that the cables are actually performing, not just for 10 seconds, but for longer. And testing everything at once, having a full system going through it as opposed to just having high-speed data going through, and it's usually fake data to begin with. So ATC is great. The science is there. What they're doing is brilliant. It's just we're finding that in a real-life system, there could be room for improvement.
And that's where THX comes in, which we will talk about here in just a moment. But there's a question in the chat room from THX1138, no less, who says he's a THX certified video calibrator. And he says, I guess it's not so much a question as a comment, and I'd love to hear your response to it. What's important is whether the cable meets the technical specification over a specific distance at a prescribed bit rate. THX logos on expensive cables devalue the THX brand. So do you agree that's what's important, is whether the cable meets technical specification over a specific distance at a prescribed bit rate?
I would, yeah.
Yeah,
Yeah,
absolutely. Yeah. I absolutely. Yes. Yeah, it has to be able to meet a particular bit rate, because anybody using a cable needs to be able to know what they're going to be able to expect as we step up, not only from a decade of 1080p and heading into UHD, but now we're going straight into high frame rate and wide color gamut and everything else that goes with it. So a comment though on talking about the devaluing the THX brand. That's it's a little sad to hear that as a comment or a thought, but I appreciate where they're coming from. I do want to point out though that there is actually a very clear distinction between what's happening now and the level of technical scrutiny that cables go through now, as opposed to past programs which really were focused on 1080p only. So now we're talking, the gauntlet of tests that THX run is really way beyond anything that HDMI cable's ever seen in any program before.
Creamy Corncob in the chat room is asking about Kordz USB cables. Now we're not talking about USB cable. I just noticed that. Well, okay. I've started the question, so I'll answer it. I'll finish it up. And this has to do with USB cables. Apparently, Kordz has USB cables that are silver-plated with 7% and 12%. Is there a big difference in performance?
First comment there is I'm loving some of these names, by the way.
Yeah, right.
People that are calling in, they're great.
I love these. I love the screen names in the chat room. Yeah, exactly.
Yeah. There's, let's just say it's another brand that's doing that with USB. We're not. It's not Kordz.
Okay. Oh, okay. Well, there you go,
Yeah.
Creamy Corncob.
Yeah.
Then we will leave that and move on to THX certification. Kevin, tell us what's different about that. What I assume it's really a superset of the basic ATC testing. What has THX decided it needs to do in order to put its logo on a certified cable specifically? And I think we really want to talk now more about 4K, UHD, wide color gamut, high dynamic range, all that stuff that's coming down the pike. These cables better be able to carry it, hadn't they?
Absolutely. So the easy thing with cables is you don't have to worry about what's going through the cable. So it doesn't matter if it's HDR or if it's the 12-bit color, whatever, it doesn't matter. All we care about is the bandwidth. So how much data you're trying to cram through. So what THX has essentially done is taken some of the constraints that the HDMI ATC does and actually just tighten them up a little. There are places where we felt the places they had set their targets were a little too loose, and because they're testing one specific element in a controlled lab setting, it's not really a real life, because if you have a marginal source and a marginal sink and maybe a marginal cable on independently testing one of those, they might pass ATC, but when you put them together, suddenly you have failures in the field. So our decision was to let's make sure that we provide a little bit of buffer, just so that way if there is some marginality in other devices in the field, that we'll have a more robust overall solution. So that was sort of the one thing. Second,
okay, so in other words, testing everything at once under more real-world conditions.
Exactly, that's right.
Yeah.
So and tightening things up, so that way even if we're just looking at jitter independently, we put a little bit of a tighter constraint on there, knowing that in a real-world application, there's other stuff happening in the system that could actually cause that to fail if it wasn't sort of in this perfect lab environment.
Right. In fact, we've got some pictures of a couple of the elements that you test for. One is called Jitter, and
Yep.
I wanted to take a look at that, and I had a question for you on that too. But let's start with just a sort of an explanation of what the heck is Jitter.
All right. So jitter, it's funny. I just read an article that had a great definition. I should have written it down, but it's basically as a signal. It's a measure of the disparity in the time base of a signal. So if you look at that 29 picoseconds, 0.07 UI, that's what we call an eye diagram. So the transitions are very clean. You can really see if it's a 1 or a 0. It's very, very obvious. The jitter, if you look on the 127 picosecond, just on the other side of that image, you can see that the transitions are a lot thicker. So that's sort of where the transition from 1 to 0 and 0 to 1 is happening over a wider time base. So there's a possibility where if there's too much jitter, the receiver wouldn't know if that 1 or 0, if the actual data bit was a 1 or a 0. So it's a measure of essentially the noise in a signal. But again, it's a very simplified definition.
Mm-hmm.
So what this image is showing you is at lower data rates, you can see that I think it's going from the top is the lowest data rate, the bottom is the highest data rate. So you can see that the higher the data rate, the more jitter, the more noise in the signal, and the harder it is to recover. So that's sort of the idea of what we're trying to emphasize, is that 4K 60 is going to be a whole new beast above and beyond even what we're seeing here.
So what we're seeing here is not that super high speed,
Exactly.
what we need, but it just gives us an illustration anyway.
Yeah. So imagine like the bottom image is basically twice as fast when we go to the 6 gigs per second than what we're seeing at the bottom.
Okay. And then we had another picture about jitter, I think. Let's take a look at that. Maybe
So this shows the errors. Basically, so I think some people aren't sure, like, how do you actually see errors, or how do you know if things are going wrong? Because the idea is it's binary, right? Either it works or it doesn't.
Right.
And it's just on that tail end where it's starting to fail, but maybe mostly there. That's when you start getting sort of the hint that there's a problem going on. So we call either sparkles or streaks, and it's usually on specific colors or transitions that you'll notice more errors. And if it's very subtle, you might see one sparkle every second, or just sort of here and there, but it's pretty negligible. And some people are okay with that, but the problem is that at any given time you're taking a probability, because if it's happening once, it could happen in a client. Basically, you could start seeing flashes. You could get some audio pops. You could get dropouts. Like it's showing that the signal is not getting to the display perfectly.
I've certainly cited that if your cable is too long, for example, instead of simply failing and not seeing anything, you'll start seeing sparklies, I call them.
That's right.
And that is that. At least if the cable's working well, it'll work well over a certain length, but as you get longer and longer, it might start to fail, right?
Yeah, and there's even like additional factors. It's not necessarily like you could have a cable that works perfectly in your first day. You set it up, you plug it in, everything looks good, and then the next day maybe there's more humidity in the air, it's hotter out, and suddenly you start getting the sparkles. And that's because there's a lot of other elements going into on the electronic side, because an equalizer's performance can vary slightly based on heat. So if you're, again, it's on those marginal cases right at the edge of failure where a thing could work perfectly one day and then not necessarily as good the next. And that's what we're trying to avoid. So we want to make sure that cables out there aren't marginal.
Man, that would be super frustrating. If, something worked one day and didn't work the next. Holy smokes.
And don't get me wrong, that's a very rare case. That's the extreme marginal case.
Yeah, okay. F-Loop in the chat room is asking, is the certification performed by testing production or pre-production samples? And does certification specify requirements for ongoing testing?
So the specification is for...
Yeah.
Oh, sorry.
Yeah, no, sorry, Kevin, you take that. Go for it.
The specification is for production versions of the cables, and what we do have is verbiage in there so that we will do a follow-up testing once it's in the market. So there's no set process in terms of making sure that we go on a yearly basis to bring new cable in to test, but we do plan on trying to validate and confirm various cables just to make sure that we're not getting sort of blindsided by these perfect samples that were sent for testing, and then potentially the manufacturing process changes.
Yeah. We product reviewers also run into something of that problem when we think about getting a product from a manufacturer that we're going to review. We wonder, is this a golden sample? Is this something that they made special for us, and then it doesn't represent what the consumer can actually buy. It's a big problem for most reviewers, except Consumer Reports and a few others, who actually go out and buy their products for testing. Now, is that something THX does, or do you rely upon what the manufacturer sends you?
Yeah, we currently rely on the manufacturers. In some cases, we'll go out and buy off the shelf if they're available. But in most cases, the manufacturer will send us their packaged product. So there's always that possibility. I think it's unless you're doing like Consumer Reports, it's very hard to control them to that level. But
very hard, yeah.
So yeah,
I can actually add to that, guys, that THX actually do reserve the right to be able to procure a cable from market in any way they see fit, which means they can literally go down to the local store, buy a cable, send it in for testing just to make sure that everything is right. So so they do want to make sure that it is actually a production version, and it literally the cables that we sent in for testing were just out of a box of cables, just pulled a few out and sent them off packaged, sealed as they were. They actually were production versions.
Ah, great. So you just took them out of your inventory and sent them along.
Yeah. So our first batch of the cables that we've got literally didn't have a THX logo on them yet, because they were finished production already out there cables that we then sent in. They weren't even specifically engineered for THX certification. It was a mark of our integrity and quality, I like to think, and confidence in the product that it would actually pass the criteria.
Yeah. Creamy Corncob in the chat room has clarified his point about those silver coating on the cables, and he miswrote that it wasn't USB he was thinking of. It was HDMI, as a matter of fact. Does Kordz make HDMI cables with some silver plating or coating on them?
We do use small amounts of silver in one of our series now. We used to have two more expensive models which did actually have higher content silver, which were some of those more exotic cables that we were talking about, but they're actually now discontinued from production, and in some markets where they actually are more critiquing the audio quality, which is what that was more focused on.
Interesting.
Have actually validated that our own findings that in most cases it's actually unnecessary, and it just adds a lot of expense to the cable, which is also unnecessary. We focus on just making sure that it's going to do what it's supposed to do, as I mentioned earlier. So those cables have gone into the channels of history.
The annals of history. I like it. Okay,
annals
very good.
Of history.
Indeed. Another parameter that I wanted to talk about is what's called slew rate. So, Kevin, define what slew rate is and why it's important.
Okay. So slew rate is basically the time delay from a high to a low transition or a low to high transition. So basically how sharp are those edges within the digital signal. So slew rate in itself isn't necessarily measured or independently measured within ATC or within the THX test. It's basically encompassed in the jitter test. And if you can bring up one of the images, I think it was image 7. Perfect. So that one shows basically the mask. So ATC basically sticks this mask on top of the eye diagram, and that's how they decide where the failure is going to be. So if there's any bits or any transitions that happen within that eye mask, then that's considered a failure. And when they went to the 18 gig, they basically made that mask smaller, putting more reliance on the EQ, which is what David had alluded to. So but because of the shape they're looking at, the slew rate sort of a compensator, or at least looked at within those boundaries. And in the similar fashion, when we do our testing, we follow a similar scheme. So slew rate is looked at and considered based on the jitter measurement.
I don't think we saw that picture come up. John, I think it's number 7.
There it is. So yeah, you can see the mask that fits it in the eye diagram. So any sort of those transitions that fall within that mask, that will indicate an error and would fail the cable.
You're talking about in the case of the upper one, it's that gray hexagon. Is that the mask?
That's exactly right. Yeah, and then the blue diamond below it.
Ah, okay. So if
it's worth
David,
pointing out at this point. Yeah, Scott, the mask that's actually shown in the upper image there is the original mask of HDMI. from way back when that they used
okay.
for standard and high speed. The one in the lower image, the much the truncated diamond is the new mask that they introduced as part of the HDMI 2 specification for the higher data rate.
Well, as you said, high speed was actually what 10 gigabits, and now we have 18. And this was something I wanted to ask you, because there's a great deal of confusion around, well, first of all, around the numbering system, which HDMI licensing has said to me for a long time, we don't want to use numbers. We don't use numbers outside of our internal discussions. And yet those numbers are floating about everywhere, you know? And in particular, we have HDMI 2.0. Let's put aside 2.0A for a moment. But 2.0 can be either 10.2 gigabits in aggregate or 18. And how do you know? Is there a way to know which you're getting when you buy a product that says HDMI 2.0?
Yeah, good question. The reason HDMI moved away from reference to version numbers is because it is actually no indicator whatsoever to anybody or what it is you're actually getting. There is no version number when it comes to cables. The only change there's ever been to an HDMI cable since inception is the optional addition of the Ethernet channel and the other different types of connectors that they've got. The Type C mini and the Type D micro and the Type E automotive. Other than that, there actually hasn't been any change to the cable specification since 2002.
Wow.
So to say there's no difference. Yeah.
I was going to say, in terms of the cable, you mentioned, adding Ethernet, and I believe, correct me if I'm wrong, but isn't it true that in the early days of HDMI cables, there were at least a couple of pins in the connector that were not connected one end to the other through the cable, and that adding Ethernet and audio return channel, perhaps, you had to then connect those pins?
Yeah, it was actually very common for, in some of the early cables, actually for CEC to not be connected, which was, funnily enough, actually a little bit of a godsend for a lot of installers out there who knew that, the first thing you ever do with CEC is turn it off. But admittedly,
CEC, by the way, Consumer Electronics Control, the ability to send control messages to different devices, like turn on, switch to this input, stuff like that.
Yes, and a lot of professional integrators that we're dealing with are also implementing control systems and the like, and CEC is really just a bit of a nagging protocol that gets in their way. So, but CEC, on the other hand, actually can work very, very well and does work better now than it used to. But there are a lot of early cables that didn't even have that connected. But that aside, what you're referring to with audio return channel, it's a little known fact that there's actually two different types of audio return channel. There's what they call single mode and common mode. And single mode is only using a single wire, which is actually a hot plug detect return path, which has always been there and no cable will ever work without it, which means that technically speaking, every HDMI cable ever made from the beginning should actually support audio return channel, and then it comes down to a mark of quality whether it actually does or not. And then the common mode was integrated in with the Ethernet channel, where it actually does use the twisted pair of the Ethernet channel to support essentially a higher bandwidth, more stable audio return path. But it's considering the Ethernet channel is really still not being utilized much, if at all, in most cases. Common mode audio return channel really isn't prevalent at all. So let me also point out at this point that even things like 3D, it's alarming how many, and when I first started working with THX probably about 4 years ago now, on various other projects, we were pointing out at that point that 3D quite often didn't work, and yet nothing ever changed in an HDMI cable to enable 3D support. So cables that then hit the market that say, we now support 3D, it's a complete furphy. It should never have happened because all cables should support it. Yeah, and it's a bit errors. What Kevin was talking about before with slew and rise times and unit intervals being the basically the readable length of a bit. That's bit errors are a very real thing, and it's actually bit errors that sometimes just whack that 3D signal, or 3D flag that actually just tells the display that it's 3D coming through and it doesn't work. So the errors can happen at all levels in the cable. So getting back to your question about version numbers, on cables, it's completely irrelevant, always has been. HDMI 2 has nothing in the specification. Remember, the HDMI 2 specification is an augmentation, an addition to the 1.4 specification. It's not a replacement of, it runs concurrent to 1.4.
Really?
That's right. So there's nothing in there about cables other than the fact to say that existing cables are now going to be subjected to this higher level of equalization in the sync device. So there's nothing magical about it. And 2.0A, as you mentioned, really is, for the most part, is about HDR, the high dynamic range, which actually doesn't add any data load to the signal anyway.
It doesn't.
So no, it doesn't.
Even though it's 10-bit as opposed to 8-bit with HD signals. I would think that would certainly add a data load.
Yeah, that actually is not part of the 2.0A. That was already there in HDMI 2. So there has it's actually the what we've seen so far of the Ultra HD Blu-ray that's on its way. They're talking about the 2020 color space as being 10-bit minimum.
Yeah.
Now I could sit here all day and actually talk about whether it's 420 or 422 or 8-bit, 10-bit, 12-bit, but the thing when it comes to version numbers is it's important to note that when it comes to devices, version numbers are irrelevant, because you can't say 2.0 and then just assume that, okay, this is everything 2.0, when we've already seen a lot of displays in the market that say HDMI 2, when really it just means that they support 60-frame 420 mode, which also is no extra data load. And then they call it, out of hundreds of pages of HDMI specification, it supports one feature, so they call it HDMI 2. It can be very misleading.
Really,
so
really bothers me, man. I got to tell you.
Absolutely, and that's why HDMI banned the practice of referring to version numbers, because it is not indicative of what a product can do. What they insist on instead is to focus on just what the product will support when it comes to devices. Which features will it support? Because that's all that actually matters. And with cables, I reiterate that most cables are being sold out there from by companies that are not HDMI adopters and are probably just for marketing purposes looking for an edge over competitors and making it sound like if they call it HDMI 2.0A that it's somehow going to be a magically better cable than a 2.0 cable, when really there's no such thing in either case.
Wow. Wow.
We're very pragmatic about that. We just tell it like it is.
Yeah, well, good. I mean, I would have thought that specifying an HDMI interface, say on a product, a TV or a AV receiver or something like that, or a cable, it would be useful, at least to geeks like me, to specify what the actual bandwidth capability of the cable is. Is it 10.2? Is it 18 gigabits over the length of that particular cable? And yet I don't see any move to really do that. Kevin, do you think that's a useful thing, or am I barking up the wrong tree here?
No, you're bang on. You're absolutely correct. Is that HDMI 2 doesn't help, and that having that 18 gig specification, so that way you know exactly what that's capable of, is a big help. The problem is most consumers, like I think the guys watching this would understand, they'd be able to associate 18 gigs with 4K 60, 444 HDR, and all the beautiful 10-bit pixel color that they want. But the general consumer won't necessarily know to look for an 18 gigabit per second signal. So I think there's a big challenge in the industry to figure out how do you educate the consumers to know exactly what cable they need to support the actual functionality they want, and whether the TV and the actual source they have would even take advantage of that full 18 gigabits per second. Because like you've all mentioned, 4K 60, 420 is pretty much what's out there today. And I think until the 4K Blu-ray really comes out, that's sort of the only source material we have.
Yeah, yeah. And we'll see, towards the end of this year, hopefully, presumably, we will see some UHD Blu-ray titles and players that can actually demonstrate this and have that much data to run down the pipe.
Yeah.
So what just before we leave THX altogether, and we're not going to leave it altogether, but what else can you tell us about the THX certification process that distinguishes it from the normal quote unquote testing?
Yeah, no, absolutely. So again, the main thing is the real life scenario and burn-in. So basically looking at pixel errors as well as DDC errors over a longer period of time, and that's just
by the way, what's DDC?
So that's the, oh gosh, you're catching with all these acronyms. I should know
I
this.
know. That's what I'm trying. I try to help people understand. You know,
display data channel.
Display data channel. That's what I thought. Okay, so display data channel, and that's what's actually managing all the HDCP is happening over that low speed bus. So we want to make sure. And I guess so part of the other thing that we're looking at is when we look at DDC, which I think we've mentioned a couple times that there's a lot of failures there. The HDCP is one of the key problems. And we'll look at the actual signal itself and then evaluate the signal to see if it's at risk of possibly failing. And then on top of that, we'll do a 2-hour burn-in to make sure that even in a live system, there's no issues. And I think on the ATC side, again, that's just something they look at a more basic level. They look at the capacitance over that specific line, and then based on the capacitance level, they'll decide if it's a pass or fail. And what we've actually seen is to get more than 18 meters, you need some sort of active component to restore that signal. And the best chips out there will actually break HDMI spec by increasing the capacitance, but will give you a perfect DDC signal on the output. So it's things like that that we're sort of trying to bring to light in terms of making sure that we're evaluating the performance of the cable and not just some specific electrical characteristic that might infer if there's an error or not. So we're looking at real case scenarios as opposed to theoretical.
I like that approach very much. Instead of measuring the capacitance and saying, okay, it passes. How does it affect the entirety of the operation of the cable? Is it passing everything it needs to with no errors, and is it getting to the end of the line intact?
Exactly. That's exactly it. So, and the last thing is really around our fitness to application testing. So it's taking that cable, and this is really in active cables, like when you have Redmere technology or anything else, or there's an active component in that. We'll also do some power up sequencing and some switching, and that's really to sort of make sure that the power up sequence that's controlled in those active cables is perfect. And that's, again, a lot of the issues out there is you might plug a cable in, unplug a cable, plug it back in, and all of a sudden you get no signal. And then you unplug it, you plug it back in, the signal's back. And things like that we want to make sure just don't aggravate installers or consumers ever again. That's sort of the dream.
David, you had something to add?
Yeah, just further to what Kevin was saying about DDC and capacitance. I mentioned right at the start of this conversation that DDC was recognised as being the environment that's responsible as the #1 cause of interoperability issues with HDMI globally. And Kevin added that high speed is actually climbing the ladder, so to speak, and will become more prevalent. That doesn't diminish DDC. So what's actually happening is we're looking at potentially having more failures out there, not less. So ensuring the cable works is more important than ever. So what the reason for the failures in DDC is remembering that it's carrying EDID one direction and HDCP keys the other direction, and we're really talking about a single wire. DDC is 2 wires, but one of the wires is for clock and the other one is the data. So to control bidirectionality on a single wire, we really need arbitration and anti-collision protocols in there. And as soon as you have rising capacitance, that actually slows the signals down. So the anti-collision and arbitration is simply not going to work as well, and there's going to increase the chance of failures in both cases. And we've 700 picofarads is the limit as defined by the HDMI specification. Now, considering it uses I2C as the protocol, that's really designed as into chip. It was never really designed as a protocol to go over multiple meters of cable. So that being the case, it's tough to get it working, and we've seen examples of 10-meter cables that have, and excuse me being all metric here, it's an Aussie thing, and Kevin's the same being Canadian. So, we've seen some spectacular fails. I've seen cables out there that are 3 times the capacitance limit, and yet there they are wearing an HDMI logo and even potentially even saying high speed when it's non-compliant because it's actually got 3 times the maximum capacitance specified. So what Kevin is doing in in the lab is making sure that everything is actually going to work, and that arbitration actually works as it should as well. So, Kevin, did you want to say another word on about the mechanical integrity as well? I think that
good question. Good point. Excellent.
Yeah, so that's the last phase. We'll actually chop up one of the cables and take a look outside to make sure that the cable gauges are accurate, that there's no unnecessary cable twists, and that everything's there. So it's really just validating that the cable is what it's supposed to be. We also do some additional retention testing on the cable mold itself. So we'll plug it into a receptacle and then measure how much force is actually used to pull that sucker out. And that's just to make sure that it's not too tight, although that's rarely going to happen, but also that it's just that it's not super loose, so that you don't have connections popping out in the back of your rack and causing no end to aggravation.
I've certainly seen the case where in some TVs, the HDMI connectors are mounted in such a way that you have to push the cable in vertically up from below. And with very heavy, expensive HDMI cables, I've actually seen them just fall out.
Yeah, exactly.
Yeah, absolutely. That is very common. The specification, as I mentioned, that hasn't changed since inception. Still, it's actually startling if you've never seen it. I actually wrote a white paper once about the tolerances and quality, fit, finish, and retention force of an HDMI connector. And it's a little known fact that the tolerances are as tight as 0.01 millimeters. It's a very, very tight specification that hasn't changed in all these years, but there's nothing in there to talk about the quality of the connector and how it should be made, only the dimensions, as I mentioned much earlier. So retention force is something, there's no excuse. There's nothing in the specification that says a connector should be made loose and floppy and fall out easily, and nor should it be made too big and heavy. We put great effort into using premium materials to make it as super lightweight and flexible as possible. There's this perception that expensive must mean that it's going to be big and heavy. Big and heavy looks more expensive, but
doesn't it?
We're the opposite. We're the opposite. We're like building a lunar lander. We're actually trying to make it as light as possible, so that and the cable as flexible as possible to take away those lateral forces, to take away the connectors don't just pop out for fun. It requires forces to pull them out. So using technologies in the connector itself, die casting, for example, zinc alloy instead of just very thin gauge folded steel. There's all sorts of ways of making a superior connector, and THX have independently recognised that is a significant issue and something that's worth addressing. And it just so happens that it's kind of a perfect marriage with what we've already been doing for a number of years.
So what else does Kordz do? You've just mentioned one thing, and I wanted to ask this question. In your design and manufacture of HDMI cables, to make sure that they pass THX certification, which you already have done. You're, I think, the first company to get 4K HDMI cable certification from THX, right?
Yes, that's right. Yeah.
So what are the things that you do to achieve that, which then will presumably translate into better performance in the field?
It may sound like a blatantly obvious thing to say, but we actually build the suckers to specification, really.
What a concept!
Yeah, you think? It's actually startling. What's actually happened over the years is price pressures, competition, as HDMI has taken this journey from being this new format through to becoming completely ubiquitous, meant that it's become a commodity item, and anything that becomes commodity is subject to price pressures, materials, labor, especially in China. All these things cost a lot more than they used to, and yet the HDMI cable is cheaper now than it's ever been. So something's got to give, and along the way, we've seen cables that have just decided to completely forego shielding because shielding's expensive. So what we do is we actually just build for maximum performance to the specification, using the best quality materials for true longevity, so that you only have to buy the cable once, and then making sure it's actually going to stay in place, recognizing that the transition between the connector and the cable itself, the actual solder point, is the probably the number one source of loss. We've seen in excess of 3 dB of loss over a single connector. So we actually use a contactless induction soldering, which ensures the best possible retention of that signal integrity. So it's all about getting everything through intact, not cutting corners, and making sure that from tip to tip everything we do is right. And unfortunately, that all costs a little bit extra money. So it may end up costing $50 for one of our cables instead of being able to buy one for $20. But like I said, you only have to buy it once, and you know that it's actually going to get every single bit through intact. Because it literally is a matter of every bit matters. Yeah,
no doubt about that. Kevin, did you have something to add there?
No, because again, from Kordz perspective, the cables, we just know that the quality is there, that they're taking everything seriously, and the reliability is what's important. And that's like when you're buying the cheap cables, they're invariably going to work, but you just lose some of that confidence that it's going to be perfect every time, and that's and that's a risk you take. But it's again, for the $2 per cable, sometimes it makes sense.
Yeah, well, as long as you're not burying them in the wall.
That's right, exactly.
I think I agree. You'd want to spend some more money to make sure that it's going to stay working well over the long haul. One last question, Kevin. You mentioned Redmere, which is an example of powered HDMI cables, which let the cable be longer because you've got some amplification involved. I know that Phase HD, the company that you also work for, Kevin, produces a system, makes a system that does the same sort of thing. Is that something that THX tests as well, and how does it affect the test if so?
Yeah, absolutely. So we have extra tests for active cables. There's an additional electrical test, and it's really on that fitness application that I talked about to make sure that the reliability is there. And what we've found is that with active cables, because we had sort of said the key issues for cables is usually high speed, then DDC, and then low speed. With active cables, it's the opposite, because the 5-volt signal, like technologies like Redmere that'll actually use the power inside the cable to power the actual EQ receiver, the chip to restore the signal, it could potentially degrade that 5 volts to a point where it could cause issues with some downstream receivers. I think Redmere is one of the solutions that does it the best. They have a phenomenal technology that does some harvesting of the TMDS line power. But that's one thing that we want to make sure. So when there is active solutions, we want to make sure that the 5 volts it's actually getting to the receiver is strong enough to drive it and to indicate that the actual source is there. And then to also make sure that the hot plug detect and the DDC channels all go in the right startup sequence to trigger basically to make sure that the signal gets through the cable.
You also mentioned hot plugging, and I must admit, maybe I'm too paranoid about this, but I always try to turn the products off before changing HDMI cables. Am I being overly cautious?
I mean, in theory, you should never have to worry about that, because the system was built to the idea where you could hot plug. You could unplug it, and then as soon as you plug the signal back in, that 5 volts is detected, the hot plug gets sent the other way, the EDID, the HDCP, so it's supposed to do it on its own. But we've seen so many times that it hasn't. So passive cables, usually less of an issue, because then the receiver and the transmitter are doing most of the work. It's when you have that active element in the middle, because then suddenly you have something that's actually interfering with the 5-volt signal and hot plug detect, and that's where you start seeing problems. So whether it's a Redmere solution, if you're going CAT-X and you're going through like an HD-Base-T or another CAT-X extender, that's when you start seeing issues from hot plugging. But we just want to make sure when we're testing all the cables that again, it's true to form, it's in a life situation. People are going to unplug cables and plug them back in, and if it doesn't work, there's something inherently going wrong.
Okay, I'm going to give the last question to the chat room. Repsol Gamma asks, and it regards interference, actually, which you mentioned there a moment ago. Are there factors such as RFI, radio frequency interference, or electromagnetic interference, EMI, that can create high error rates that can disturb what's going on? Do we have to be careful where we lay those cables, like next to a power cord is a no-no, or is that not a problem? David, let's start with you.
It does often come back to the shielding level that's in the cable. It is good practice generally with any AV cable, be it digital or analog, to keep it away from AC cables because there can be inherent RFI issues, and HDMI is subject to that. even though it's digital, keep in mind that everything that goes through any cable is still going to be time-based. We still talk about data rate per second. There is still a time base to the whole thing. The clock is also analog. So the actual carrier itself, everything is going to be subject to interference. So one of the things that we focus on at Kordz is to ensure that the level of shielding that we have is right up there. Our R.3, which is a professional product that we have, is designed for commercial rack installations. We use a full copper, pure copper braid with a 90% coverage over 2 layers of foil wrap, just to ensure that it's got the absolute maximum level of shielding available. I've never seen a higher level of shielding in an HDMI cable of any description. So our products are used in marine as well as in datacom rooms. In marine in particular, we're quite often going past little servo motors where they've got TVs in lifts and rotation ability just on little motors, and we've seen them fail just as soon as somebody actually just goes to rotate a TV a little bit by remote control, and the picture drops out. And use one of our cables and it doesn't. So shielding is very much an issue. Yes.
Kevin, you agree? We need to worry about shielding here and RFI and EMI, right?
Yeah, to a certain extent. I think it's a signal to noise issue. So if you're going short cable lengths, again, the signal is going to be high enough that the noise from any EMI interference is going to be negligible. But when you're going 15 meters, 10 meters at 4K 60, by the time it gets to that receiver, the signal, there's not much to it. So any little noise that gets on that channel, it gets boosted along with the regular signal, and suddenly you have issues. So it's definitely something to think about. I think it'll be more noticeable as we hit the 18 gig signals,
which are coming right upon us, and some of them are already here. So
that's right.
With that, I will thank both of you very much for being here. It's been a fascinating hour, and I've learned a lot, and I hope our audience has too, about HDMI cables and testing and certification and all that stuff. David Meyer, founder of Kordz, all the way from Melbourne, Australia. Thanks so much for being here so early in your morning.
Oh, thanks for having me, Scott.
And
really
you bet, my pleasure. And Kevin Taylor, a consultant at THX, currently in Toronto. So we've spanned many time zones today. Thank you so much for being here, Kevin.
Thanks a lot, Scott. It was a great time.
You can find out much more about THX, of course, at thx.com, and about Kordz cables at kordz.com. That's KORDZ.com. And plenty of information at both those sites for all of you home theater geeks out there. You can always find me, of course, at avsforum.com. You can email me at scott@twit.tv. And you can follow me on Twitter at htgeekscott and at avsforum. And you can always find previous episodes of Home Theater Geeks right here at twit.tv/htg and on our YouTube channel at youtube.com/twit Home Theater Geeks. Next week's show will be devoted to answering your questions. If you remember, we were going to do a Q&A show early the first Thursday of July, but that got usurped by the report from the Value Electronics flat panel shootout. So we're going to do that next Thursday. And I'm going to be joined by my colleague at AVS Forum, Mark Henninger. So I do hope you will join me and get those questions ready, because we're going to have a spirited hour of conversation, I'm sure. So I do hope you will join us. Until then, geek out.